So this question comes from the house of matrices and determinants. It is a type of question stem of question number 7 and 8. Let alpha, beta, and gamma be the real numbers such that the system of linear equations, this, and this, is consistent. It means that there exists a solution. So for consistency, let us check the consistency. We can see that delta is 1, 2, 3, 4, 5, 6, 7, 8, 9 is 0, and delta 1 for consistency. If delta equals to 0, then delta, all the three deltas must be 0. So you could see that delta 1 equals to alpha, beta, gamma minus 1, 1, 4, 7, sorry, 2, 5, and 8, 3, 6, and 9 must be equals to 0. These system of equations must be homogeneous for to be consistent. So there comes equations involving alpha, beta, and gamma, which is nothing but the plane consisting the points alpha, beta, and gamma. Our first question is to find the value of m. Since these three equations must be homogeneous equations, so alpha must be equals to 0, beta must be equals to 0, and gamma minus 1 equals to 0, which gives alpha, beta, and gamma as 0, 0, and 1. Plugging these values into the matrix M, will get the determinant of M as 1. You could easily see that 0 to 1, 0, 1, 0, minus 1, 0, 1. So expanding along this column, it will give 2 into 0, 0, minus 1 equals to 1. Then we are required to find the square of the distance of the point 0, 1, 0 from the plane P. Let's find out the determinant of this delta 1. So 45 minus 48 minus beta, 18 minus 24 minus 6 plus gamma, gamma minus 1 times 12 minus 15 minus 3 equals to 0. We will get alpha minus 2 beta plus gamma equals to 1. This is the plane equation of a plane consisting the points alpha, beta, and gamma, or we can say that it is the locus of the points alpha, beta, and gamma. So d equals to square of the distance of a plane from a point is alpha minus 2 beta plus gamma minus 1 over root 6 square. It is 3 by root 6, which is nothing, 9 by 6, or 1.50. It will be 1.50. You will find a detailed solution of this question in my GitHub repo. There you can see the solutions of all the questions. handwritten solutions of all the questions with the name JEE 2021 question number and then paper number in my GitHub repo JEE Advanced 2021 solutions. Now move to the next question. Another question comes from the house of the conics. And please forgive the technical glitches that we are seeing. Uh, in this, we are given two lines L1 and L2. These are the two lines, and for a fixed constant gamma, let C be the locus of the point P such that the product of the distance from P from L1 and the distance from P from L2 is lambda square. This is these are the two lines, and we can see that it intersect at the point 0 comma 1, and and its locus the distance from the point L1 and L2 is constant. This locus is nothing but a hyperbola, because recall from the concepts of conics that if the product that this is the that if the product of a distance of a point from two lines is constant, then the locus of the points will be a hyperbola or two hyperbolas, two set of hyperbolas like this of same eccentricity. Okay, of a fixed eccentricity. It means that the flatness of the curve remains constant. Like we are given a fixed, suppose, iron thread, and it does not change its orientation anyways. Let us find out the locus. L1 is root 2x. Oh, L1 is x root 2 plus y minus 1 equals to 0, and L2 is x root 2 minus y plus 1 equals to 0. But we have been told that dl1 dl2 equals to lambda square, that is, let the point P be h comma k first of all to find the locus of this point. So it will be h root 2 plus k plus 1 times h root 2 minus k plus 1 by 3 equals to lambda square. And from here we could see that solving this equation is a bit tedious, so we will shift our origin to the intersection of these lines, that is 0 comma 1. So we'll put in a new set of coordinates, we'll put x equals to x minus 0, y equals to y minus 1, and good, and we would get the two lines as L1 x capital X root 2 plus y equals to 0, and it will be capital X root 2 minus y equals to 0. And the line L, which is initially y equals to 2x plus 1, will be nothing but y equals to 2x. So our this equation will become x root 2 plus y into x root 2 minus y equals to lambda square into 3, or 2x square into y square equals to 3 lambda square. Clearly we could see that this equation gives the set of the two hyperbolas. Suppose C1 and C2, and the equation for C, the locus of the point will be this point, this curve. The first hyperbola is 2x square minus y square equals to 3 lambda square, and the second hyperbola is y square minus 2x square equals to 3 lambda square. Clearly one hyperbola is the conjugate of the other. So suppose these are two lines, root 2x minus y equals to 0, root 2x plus y equals to 0, then we get first hyperbola. It is C1, C1, C2, C2, and we could see that the line LS, after shifting, we get y equals to capital Y equals to 2x, passes through this point because this is origin now. So if it cuts one branch of the hyperbola, it will not cut. If it cuts C1 here, then it must cut C2 here. It will not cut C2, C1. So this point is R, this point is S, and we are given distance RS equals to under root 270. From here we could find out lambda. Let's see. Distance between the point RS is x1 minus x2 square plus y1 minus y2 square. It can be written as x1 minus x2 square plus, if it, suppose this is a curve and this is x1 y1 x2 y2, this is the line L. So put the equation of line, since L equals to y equals to 2x, so here it will be 4 x1 minus x2 square 2 modulus of x1 minus x2 is under root 270. Now we have the equation of C as 2x square minus y square equals to 3 lambda square, or we could put y equals to 2x because this curve intersects the line. So it will be 4x square 3 lambda square, 2x square equals to 3 lambda square, x square equals to 3 by 2 lambda square. It will give two values of x1 and x2, which are x equals to plus minus root 3 by 2 lambda. Lambda is a constant, it's not gonna, okay, there will be mod because it's not given whether it's a lambda is greater than 0 or lambda is less than 0. So for playing with the safer side, we'll put lambda as modulus of lambda here. Square root of lambda square as modulus of lambda. So we'd get x1 minus x2 is 3 by 2 mod lambda. So 2 into 3 by root 2 mod lambda equals to under root 270. From here, mod lambda will be sorry, I've committed a mistake. It will be root 5. It will be root 5. Here it will be root 5. So we would get lambda as mod lambda as root 270 by 5 into 2 by 3. This will be 54 and 18. Lambda as 5 x1 minus x2 equals to root under 54. This is root 54. I think I've committed mistake here. So root 54 equals to root 3 by 2 mod lambda, or we would get one second, mod lambda x so minus x2, x1 minus x2 will be 2. 12 by 2 mod lambda will be root 9, implies that lambda square equals to 9, which is the answer of the question number 9. The answer would be 9. Now move to the next question. If you want detailed analysis of the graph of the function, then wait for some time. I'll upload an animated video on this. Sooner the better. Now the perpendicular bisector of RS meet C at two distinct points R dash and S dash. Let D be the square of the distance between R dash and S dash. In this, we are working on the working by shifting the origin, because the questions that have been asked are related to distance, not as the coordinates. So it will be easier if we play by shifting our origin, because distance is not affected by shifting the origin. So y equals to 2x L dash, that is the perpendicular bisector of this line, would be y equals to minus 1 by 2x. I have written this directly because I've used the symmetry of the problem. problem is symmetric about the point 0. So L dash would be y equals to minus 1 by 2x. And we have to again repeat the process of finding the distance. D R dash S dash would be x1 minus x2 square plus y1 minus y2 square. Again, by putting this, we would get root 5 by 2 mod x1 minus x2. So how we could find x mod of x1 minus x2? We would use C. Is 3 and lambda square is 9. 2x square minus y square minus 1 by 4y square equals to 27. It will be 7 by 4 x square equals to 27. X square equals to 27 into 4 by 7, or x equals to 27 by 7 times root 2 plus minus. So x1 minus x2 mod will be 427 by 7. So root 5 by 2 into 4 into 27 by 7 equals to the distance. And we are required to find the square of the distance. So 5, 4, 16, 27 into 7, 4, 20 into 27, 540 by 7, 49, 9, 5, 77.1428 is the answer to the problem 10. This was also a type of moderate question, but we should do it carefully because a lot of calculations have been involved. So again, the technical glitches, and let's shut down it here only.